Hey folks, before we get started, I just want to let you know about my upcoming book, The Max Coder's Guide to Finding Your Dream Developer Job. If you're looking for a job, or you think you might be looking for a job in the future and you're trying to up your mobility and meet new people and things like that, this book walks you through the whole process. Go ahead and check it out. It comes out on November 20th. It'll be on Amazon, and you can find it as The Max Coder's Guide to Finding Your Dream Developer Job.
Hello and welcome to another episode of Adventures in .NET. I'm Shawn Clabough, your host, and with me today we've got a special person, and that person you probably are familiar with. It's Scott Hunter from Microsoft. Hi Scott, how you doing?
I'm doing great.
You know, Microsoft has so many Scotts, I think I should change my name.
Well, you notice I'm wearing the red shirt today.
I know, you're trying to impersonate one of the other Scotts.
Yeah, I didn't see Scott Guthrie here today, so I thought I'd wear a red shirt to try to mimic him when I was on stage. So,
Awesome. You confused me a little bit there. But then there was another Scott, so I knew there was two Scotts there. Where's the third one? And I thought you were missing.
Yeah, the real challenge is Scott Guthrie has less hair than me, so that's the easiest way to tell the difference is probably the hair.
Okay, I'll pay attention to that next time.
Have you ever felt like JavaScript is just everywhere? Well, we have. We actually had a conversation on JavaScript Jabber about what you can build with JavaScript. We've also talked about what JavaScript is and how we're inspired by the language. If you're interested in JavaScript or doing web development, then you definitely need to check out JavaScript Jabber. You can find it at javascriptjabber.com.
What we have you on today for is talking about the new .NET Core with 3.0. You know, there's been a lot of announcements here at Ignite, and then also a number of announcements at .NET Conf, which was a really good conference that I watched and enjoyed there too. So I know you're in charge of all that stuff, so you should be the most knowledgeable, right?
I can try.
Okay. So I think the biggest thing for developers out there with Core 3 is the changes with the C#. Coming up to version 8, there's a lot of things that are new in C#. Talking about nullable reference types, different types, span and range, switch extensions, pattern matching, async streams, and even default implementation. What are those things, what do they mean to you, and what does that kind of mean for the developer world?
There's a couple of those that I'm a big fan of. One of those is I love the range stuff. We've all done programming where we pass arrays to something, and sometimes you want to pass a subset of that array to something. So what do? Before you pass it, you make another array.
Right.
And you copy some elements out of that. Something like you do some kind of loop with length -1, minus, and then you go back a few, and some of the range tech just basically lets you give an expression saying, I want the last 3 elements of the array, or I want the last 2 elements of the array, or I want the first 3 elements of the array, or I want between the first on this end and the last on this end. That's going to save you some programming and save you from making some mistakes with that length -1 stuff. So I'm a big fan of that one. I think one of the ones that will be most impactful in the long term is going to be the nullable reference types. Mm-hmm. That was something that we did a bunch of data collection on to see, hey, what kinds of exceptions do .NET apps throw the most? Well, they throw null reference exceptions the most. So, we asked ourselves, is there work we can do in the compiler and the language to help that? And so when you turn nullable references on, the compiler will start enforcing to make sure you're actually making null checks yourself.
So that's only a design time thing, right?
It's
when you're
primarily
building and you're compiling.
Yeah. It's when you're building and compiling.
If it makes it to runtime, it's not helping you.
Of course not.
Right.
And so the idea is to catch it before you get to runtime. It's like if you want to make that an error in build, you can make it when you get one of these warnings, you can turn that warning into an error, and then suddenly you're not going to even be able to run the app until you actually go fix all the null checks in your application.
One of my first thoughts when I heard about that was it was handling all the strings. It seems to me that you'd almost end up putting all of the strings back to being nullable, being okay, or the other alternative would be initializing them all to like string.empty.
Yeah, I think the right thing to do and what the tools will actually try to enforce you to do is put the question mark on the strings, which means they can be null or they can have a value. Strings are actually probably one of the craziest ones here because they have all those different states.
Right.
They can be null, they can have a value, and depending on what you pass them to, that can be legal or not legal. And but yeah, the compiler will start enforcing you to put those question marks on. If it sees a string by itself, it's going to go, no, you should put a question mark on there because it could be null.
Right. So I work in the full framework 4.8 world.
Yep.
And I was actually able to turn that on my project. and it scared me. So, I mean, the counter for all the warnings just went sky high, and I went, whoa. But then I found out that you can actually do it the opposite way, enable it, but then only enable it for certain files.
Right.
And that really made it a little bit more, bearable, and try to figure out and try to learn what it's going to take to get through the whole thing. And you can do it piecemeal and just page by page.
Imagine what it must have been like when Emo and my team turned it on for the BCL, which is the base class libraries. All the libraries that we ship, they spent weeks and weeks and weeks fixing our own code to actually, support that and make sure that we actually were, returning those things if you wanted, fully supporting it. That's the real challenge about nullable reference types is even though it's a feature you can kind of turn on file by file, as you said, the likely chance is you're using NuGet packages that are written by authors of libraries, and until they actually all embrace nullable and put nullable through all their code, we won't get the full benefit of it. So we think it's actually something that will take a couple of years to fully filter through the system. I think I'm gonna butcher the number, but I believe that Emo just recently looked at Net Standard, and we looked to see at NuGet.org. When we shipped Net Standard 2.0. A couple of years ago, obviously the number of NuGet packages that supported it was like 0. And I believe it's about 58% of the NuGet org now supports Net Standard 2, which is awesome because it means, all those libraries now work on any .NET project, whether it's a Xamarin project or a UWP project or a WinForm or a WPF or an ASP.NET. And so it took us a couple of years to get, Net Standard 2 to go that far through NuGet. So it'll take us the same amount of time probably to get nullable to go through there as well.
Mm-hmm. So is it out there with the BCL right now? Has it been set that way?
It is. So we've done our stuff already, and it just requires people to do the work for their libraries now as well. And part of the challenge for the authors of those libraries too is you have to hack around it a little bit because you might want to still support the .NET Framework 4.8 people, and so you do some tricks and stuff to get your library to kind of be both at the same time. One more language feature that it's kind of my one of the coolest ones is in some of the demos we've been putting on recently, we've been showing GRPC. Think of GRPC, something like WCF or REST. But one of the cool features about GRPC is it supports something called streaming, where instead of just returning a single result, it can keep returning result after result after result. And typically in C#, if you're gonna code against that, you'd want to do like a for loop and a for each and kind of for each against all those results. That wasn't possible in the past because we had no way of doing an IEnumerable, which is what for each lives on top of, in an async way. And so we've also added the ability to do that now. So IEnumerable supports await. And so in one of my GRPC demos, I was doing await for each var, result in stream, and it's doing all the async stuff, and it makes that for each loop just look like a regular for each loop, but it's doing async behind the scenes, which is really cool.
No, that is really cool. Another thing that I played around with a little bit was the pattern matching. I found that really handy too. So what was the thought in there, and what are the use cases for it?
So I'm going to turn that back on you for fun because pattern matching is something that I like, but how did you discover it? Did you read a blog or did you read some of our docs? Because
it was part of a docs. I always look, okay, what changed? I'm using C#7. C#8 comes out. Okay, what's new? What's changed? Is it worth me, making that switch and trying to pick up some of the new enhancements to it? Like I said, I'm with 4.8. Some of the early information made it sound like I was going to be able to use that in the full framework, and then I started hearing something like, no, it's core only. Then I was kind of a little disappointed there, but then I found out, okay, let me just try to turn it on, and it did enable some. I don't get the new types, spans and ranges and things like that. Right. But some of the other syntax stuff did work for me.
Yeah, that's actually a good subject. Actually, you ask, why did you do it this way? Why the change? One of the big things that we're trying to do with the tech all up is, historically, what we've done is we said, hey, we build a new feature. Let's go find a way to put it down level. That's what we'd call putting it into an older framework. And so when we did things like the initial await stuff, it sort of worked. You didn't have to use 4.5. You could actually run older code and use some of the out-of-band compilers and stuff to make it actually work on older stuff. What we found is every time we ported a feature backwards, we broke stuff. And so myself and John Cunningham, Jock is how he's known in the team, he and I are real sensitive to breaking things in .NET Framework these days. We hate it when there's a an update to .NET Framework and we break a bunch of apps, or there's a Windows update and we break a bunch of apps. And so as we went into .NET Core 3, we kind of said all the new stuff is only going to be .NET Core 3, because every time we backport something into the old framework, something gives somewhere. We actually had this happen to us with .NET Standard, actually. Mm-hmm. We actually broke .NET 4.6 and .NET 4.7 with .NET Standard initially, because we tried to make it work, .NET Standard work backwards into those versions of .NET Framework, and we got it wrong.
Yeah, so I imagine one of your mantras is going to be, don't cause pain if you don't have to.
Exactly. And so what we did in C# 8 is we decided not to cause pain, meaning that we're not going to put it backwards. But at the same time, some of the features don't require runtime support. And so some features in C# are only the compiler, which means it doesn't matter what .NET you're using them against. And some features require code to be inside of the actual runtime. You mentioned things like span. There's runtime work in the span stuff. And that's why people like yourself that are savvy, if you want to go flip the switch and put the C# 8 in your project file, you'll get some of that stuff, and your mileage may vary. We're not going to tell you not to do that. But I wanted to explain to people on the podcast why, hey, why did you not just move these things backwards?
Right.
The risk of breaking stuff. Our job in .NET Framework really is not to break people.
I'm still trying to decide which of the using syntax I prefer. So do I still like that block scope? Do I know that that's where it starts and that's where it's end, or do I just let it fall to the next outer block? So I'm still trying to...
I sometimes like that. So I've used that a few times so far, and I do like that. And for people that are listening, you can put usings inside of blocks now.
Right.
And you could not before. And so it kind of scopes the using to a smaller chunk of code than before. I have found it useful, so I like that one.
So tell me a little bit about side-by-side support and how that works in Core 3.
Yeah, so side-by-side support is something that was a key tenet of .NET Core 1 all the way through 3 today. And it's actually one of the reasons that when somebody comes to me and says, Scott, why would I choose Core over .NET Framework? Why would I, this is one of the reasons. And to give the background on this, we were just talking a second ago about if I move something into the older framework. So the reason that's dangerous is because Windows ships .NET Framework. When you install Windows 10, it will come with a version of .NET Framework. And for size purposes, the Windows team only lets us put one .NET Framework on the machine. So there can only be one. And what we learned over time with that was because there's only one singleton on the machine of .NET Framework, well, you built your app on .NET Framework 4.7, and we fixed a bug in 4.8, and then your Windows updates to the newest version of Windows. Now you're running .NET Framework 4.8, and your app breaks. So we don't want that to happen. That's for us, that's a terrible thing. It's like, oh my God, I feel like I broke something, and I broke somebody's app. I don't want to do that. At the same time, because we don't want to break you, it also meant with .NET Framework, we got to a point where we no longer could innovate. Because my fear is anytime I change something, I might break you. I was around in 3.5 SP1 where David Fowler and I fixed 2 bugs in ASP.NET. We're like, oh, we can fix these 2 bugs. And the reality is a lot of people actually were depending on that bug. There's some ASP.NET code you could write that didn't do anything, which is why it was buggy. But people put it in, it didn't do anything, and so they just left it in. So we fixed it, and suddenly that code started doing something again, and it broke a bunch of apps, and I got in trouble. So when we built .NET Core, a tenet of .NET Core was side-by-side, meaning that you can install as many .NET Cores on a machine as you want. Like you could have a machine with 1.0, 1.1, 2.0, 2.1, 2.2, 3, and 3.1. That is totally supported. And if you have an app on the machine, the app can actually physically say, I want to only use .NET Core 2.1. So even if you add a 2.2 or a 3.0, it will not roll forward to the next version. It is pinned to 2.1 until you tell us otherwise. So that's just a key piece of the way we wanted to build .NET Core.
So that puts a lot of onus on the developers if there is a security fix in a newer framework version and they still have theirs pointed to an older framework version.
Not so much. Yes and no. So we do have the ability to roll forward to a dot version on one of those. So for example, you can say, I want to be on 2.1, but I'm willing to take 2.1.1, 2.1.2, 2.1.3.
So kind of semantic versioning type of...
Exactly.
Yeah.
And there's another mechanism in there where we have the ability, if there was ever a awful, what we would call zero-day patch, we can kind of force the patch onto certain versions of .NET Core on the machine. We've never had to use that mechanism because we never had a bug that bad, but we did create that mechanism in case something ever happened. It's software, never know.
Yeah, it's good to know it's there.
But with .NET Core 3.0, we added a new wrinkle to the side-by-side. So when we built side-by-side, you have two choices. One is you can install as many .NET Cores on the machine as possible that you want. There's another option that's been there since .NET Core 1 as well, and this is called like self-deploy. And what it is you tell us that you want us not only to put, when you compile, you can run the publish command, and the publish command will take the, you have to go give us the RID, that's the identifier that tells us what flavor of .NET Core you want. Do you want WinX64? Do you want WinX32? Do you want ARM or whatever? You give us that, and you tell us you want to be self-deployed. And what we do is when you run the publish command, we will copy all the DLLs from .NET Core and the DLLs from your app into the output folder, which means that's a self-contained pile of stuff. You can copy it anywhere. It does not require .NET Core to be on a machine, and that folder will run everywhere. And that's for maybe you're building a microservice and you don't even want to have .NET Core on the machine. You just copy that folder up and your app's going to run just fine. We added a new wrinkle in 3.0, which is you can add a new line to your CS proj telling us that it's self-contained. And in that case, what we actually do is we turn all those DLLs into a single exe.
Nice.
So what we'll do is we'll take the DLLs from your app, we'll take the DLLs from .NET Core, we'll stick them all together into a single file. Now you just copy one file to another machine, and your app will run. We also added an experimental feature, and it's only experimental because we only got it working in the tool chain late in the game of 3.0, which means we haven't had customers try it a lot, and this is our linker. And so on one of the demos that Scott Hanselman and I did today, we took a application, and when we started off the application, we said make it a self-contained exe, and it was 190 megs. Which in today's world is not crazy. I mean, drives have gotten a lot bigger. But then we turned on the linker, and it was actually 160 megs. And it went from 160 megs to 89 megs. So we basically linked away 60 megs of the framework that you were not using. And so when you turn this feature on, what we do is we try to determine which DLLs in .NET Core that you're using, and any ones you're not using, we throw them out. Right now, it's not that technology doesn't have GUI associated with it. You have to go to the CS proj and manually put the code in to make that happen. Likely in a later version of Visual Studio, we'll actually have a property page where you can set that you want the linker turned on, and maybe you set how aggressive you want it to be. There is a backdoor. The linker can link something out that you're using. For example, let's say you use reflection to load an assembly. Well, the linker's not going to know that. It's going to throw that other assembly away. And so what you can do is if that happens to you and you get an error in your CS proj, if you hard reference that package or that assembly, then we'll not throw it out no matter what. But that's a piece of the tech that we hope to get better and better over time, because I want to let you have these single exe applications, make them as small as possible. And so as I said, today it's CS proj only, and at some point we'll make it a tool thing where the tools in Visual Studio and VS for Mac will actually help you there.
So somebody out there that's mostly a JavaScript developer, this will be similar to tree shaking to them.
This is a lightweight version of tree shaking. Today, we do the tree shaking at the DLL level. In the future, I'd love to do it sub-DLL as well. That's where we can really make things super small, is by doing it below the DLL level, where we actually analyze the DLL and find out what you want. But yeah, things like Webpack and stuff would be the tech that you might be using in the JavaScript world to do the same thing, because the NPM restores on some of those JavaScript things are huge.
Right.
Like multi-hundred megs. You probably don't want to have multi-hundred megs in your website, and so they have a tool chain for that. And by the way, the UWP apps have done this forever. So if you build they were using a tech called .NET Native, and .NET Native does this exact same thing, and it's way more aggressive than the one that we have.
No, I did not know that.
Yeah.
Yeah. So is single exe, is that available to all application types?
All application types.
So you could make a web app and make it a single exe, and it would you have to put that in IIS, or is it going to be its own web server as well?
It'll work. You can run that single exe with Kestrel. You can run that single exe in IIS. It's basically the same collection of files that we would have run anyways. It's just putting them all together. The web stuff might be a little more challenging because we use a bunch of dependency injection with the web stuff. And so it might link out more than you want by default. Oops. And that's why we did not make that's why we didn't put this in the property sheets on the app yet, is because we know that here's the way we think of this right now. If you really care about size, you're probably willing to do the extra work to go figure out how to fix it when it breaks. But until we get it to a point where it's like, hey, you check this, we know that you're a web app, and we know that web apps use these DLLs, and we should not link those away. That's why it's not on by default or there. But the plan is to make it available for all types. And as we move to .NET 5, we want to make those apps even smaller and smaller.
So I've done some research, and I've asked a few people, when you're using a single exe and you click on it, where do all the files go?
Yeah, so that's an interesting question. So the way that this actually works today is the single exe is actually a little stub, and all of the DLLs are actually part of they're in the resource part of the application. They're resources inside of the application. And so what happens is it takes the app and copies those from the resource section of the app into a temp folder and runs the temp folder. And so there is a small hit on startup as we do that uncompress to break all the stuff out, but you'll still get the single exe. In the future, in the .NET 5 wave, we'll get rid of that uncompress and actually just run the single exe as a single unit. That's a lot more work. We didn't have time to do that in 3.0, but we do think that there's plenty of value in the way that we did it for 3.0 as well that people will get a benefit from. And that's why we shipped the lighter version of this. We actually, the tech we used for that came from Xamarin. Xamarin has this exact same tech for some of their mobile apps. And so we took their linker and used their linker to do this. Hey, it's one .NET team. We get to use all the bits from all the teams.
That's right. James, thank you very much. So we had another show on Blazor earlier in Adventures in .NET, but there's some changes, some minor changes coming between Core 3 and Core 3.1. What are those kinds of? I'm
gonna fork you a little bit and say anytime I get a chance to talk about Blazor, there's some confusion in the marketplace, and I'd like to talk about that confusion. We shipped Blazor 3.0 or Blazor 1.0, 3.0, whatever you want to call it. Blazor, the first version of Blazor shipped as part of .NET Core 3, but there was, I don't know if you saw the blogs. There was a blog by somebody saying, no, you shouldn't use that. You should wait until the client version of Blazor ships next year. And the podcast would be a great place to have this conversation. Sometimes we're a little bit overzealous when we talk about Blazor. We're like, oh yeah, Blazor, you can run server-side, you can run client-side, you can do all these things. It's really cool. It's WebAssembly. What I want to tell my customers right now today is Blazor Server is a great way to run your applications. We ship the server version of Blazor because it's going to take us a little bit more time to get the WebAssembly fully running. But the cool thing about Blazor as it is today, if you build a Blazor component, it should be able to run in either the server Blazor or the future client Blazor. So the idea is you build components today, they should work on either sides. People ask us, well, what's the scalability of Blazor Server? To explain to people on the podcast, here's how Blazor works. If you're running Blazor Server, we render a page, and as that page is rendered, we also create a socket connection with SignalR back to the server. And then as the user takes an action on that page, let's say we're doing the default counter page that has a button, you click the button and the number increases. What actually happens when you click the button is we send a command down to the server telling the server that you just clicked that button. Then the server, in memory, re-renders the page. It knows what the page looked like before. It re-renders it again after you click the button. It runs the code to run the button. And then it takes the diff of those two pages and sends the diff back up the wire to the client. And we have some JavaScript on the client that runs. It basically paints the delta of that, which means when you click that button, 6 or 10 bytes go down to the server, 5 or 6 bytes come back up from the server, and that number updates on the screen in real time. And so because of that architecture, it means, if you're thinking about that, you might be going, okay, here's how I would think of this, is it means the server has a copy of all the pages all the time in memory. Right. Because it has to be able to do that diff to make the tech work. And so some people challenged and said, hey, this tech's not scalable. We did scale test it at Microsoft before we shipped with tens of thousands of clients and on a pretty beefy machine, and it hung in there quite well. So we do think the tech is ready today for people. Now, there are some challenges. I think you and I talked before we got on the podcast. There's some challenges around state management. So one of the things that Blazor Server does have as an issue is If for some reason you're disconnected from the server, there's no way for Blazor to know where to wire back up to again to get that diff. And so you kind of have to click refresh in the browser and kind of restart the session a little bit. And that's an area that we will obviously look at working at and making better. That's kind of a state management thing in the future. But a cool aspect of the server-side Blazor is, when you look at SPA applications, you build an app in Angular, React, Vue, or whatever. If you look at the payload going to your browser, normally it's at least a meg, if not more. The same Blazor app's going to be a couple hundred K. Like if you run the default template in Blazor 3.0, the most pages are like 204 bytes. It's just the HTML. So I think Blazor Server is awesome from the standpoint of it gets you into, your app is a SPA application. It's got a very lightweight profile on the machine, and for the most part, because it's sending a lot less data back and forth. If you refresh the entire page, well, that's 204 bytes. If you just click the button and we send the command down and send the diff up, that's 6 or 8 bytes. So it should be a pretty responsive, pretty fast thing as long as you're not too far away from the, the server. And so I just want to make sure that's one of the things that when we talk about Blazor, I want people to realize Blazor's not just about WebAssembly and running the whole app in the client. This is a core piece of Blazor as well. So, then the next piece of Blazor is Blazor Client, and that's currently in preview. And that's the version of Blazor that we use, WebAssembly. And WebAssembly, for people that don't know, is a mechanism for you can compile code to WebAssembly, and the browser knows how to execute that. And so there's WebAssembly implementations for C++. We have the one for C#. There's ones for Java and a variety of programming languages. And it enables the browser, to be kind of democratized. Instead of being, you have to write JavaScript. Well, no, now you can actually use whatever language and whatever tech you're more comfortable with, and in many cases, the right tech for the problem. If I'm going to try to port Adobe Autodesk to the browser, I don't want to rewrite the entire thing from scratch. So I'd want to use WebAssembly and my existing C++ implementation to paint the screen. So we have Blazor Client that'll come out next year. And when I think of Blazor Server and Client, I like to talk about why would you choose one over the other. I think Blazor Server works great for a lot of scenarios. Blazor Server, because it runs on the server, you get access to all of .NET Core. You can touch the file system. You can do anything you want on the machine because it's your server. Once you go to Blazor Client, the world changes. Now you're running inside of the sandbox inside of the browser. When you think about WASM, WebAssembly, a lot of people are fearful of, oh my, we've done Flash, we've done Silverlight, we've done ActiveX, all these things that ran in the browser. We had Java Server. We have had a variety of tech that ran in the browser, and you always read about security risks, and there was patches for all those things all the time, because if there's a hole in one of those things, it's running as full admin and can kind of take over. And so for Blazor Client, you're running inside of we call the sandbox of the browser. Browsers are written in a way today to make sure you don't leak out, which means you can't touch the file system, you can't touch the registry, you can't touch a bunch of things. And so realize, as you move to client, your capabilities shrink. But one capability grows, and you suddenly have the power of the actual client machine. My favorite example of this is try.net. You can go to try.dot.net, and that's some tech we built so you could run .NET in the browser. Well, I'll tell you how this actually worked. We first built that tech, and what happened is you get a web page, you write some C# in the web page, you press run. We sent the code down to the server, we ran it on the server, it got the answer, we sent the answer back and painted it on the screen. That was great until we started getting the bill for the server. You can imagine how this is going to go. We put this thing in many of the documentation pages on docs.microsoft.com, and at the end of the day, we get a huge bill. And so a great use for Blazor Client is when you want to take advantage of the CPU on the client browser. So that website I just said, try.net, that actually is one of the first things we moved to Blazor Client. So now when you go and write your C# in the browser or do one of our tutorials and you press run, what we try to do is we try to run it locally first. And if we can, if it works, we use that version of it. Only if it doesn't work do we go to send it to the server and run it there and bring it back, which meant my bill went down by 600%. My bosses are happy because the bill goes down. So that's a use case for Blazor Client. Another use case for Blazor Client is what we call a disconnected app. I want to build a web app, and I want to use it on an airplane with no internet. Well, because the Blazor Client app, all the code is in the browser, it can all run whether there's internet there or not. And so that's a scenario for Blazor Client. And the other scenario, I think, for Blazor Client that I demoed today with Scott Hanselman is PWA. And that's where you have an application, it's a web app that appears to not look like a web app. You can take a Blazor Client app today, and there's a NuGet package called Blazor PWA. You add that to your Blazor application, and what happens is it adds a build task. That build task will actually write all the stuff into your www.root folder. It has icons for the application because it's going to show up on the desktop. And it's got a manifest. The manifest tells the browser what all files have to be downloaded and cached for the app to run. And it's got a couple of worker.js files to make that work. And so I was demoing today. You take a Blazor Client app, you put the PWA package in it, you compile it, and then what happens is the browser will ask you, do you want to install it on the desktop? And then from then on, when you click the app on the desktop, you don't get a browser, you get a real desktop shell window with your app running inside of it.
And can that auto-update?
Yes, it can.
Okay.
Sorry for hijacking your question about what's new in 3.1, because the stuff new in 3.1 is partial and a few other small things that affect some of our more advanced developers. But I really want to clarify, one of my goals the next 6 months is to clarify what's Blazor Server and is it okay? What's Blazor Client and when would I want it? Because when I go talk to the community, I get this impression that everybody thinks Blazor Client's the only thing they should have. And that is not the case. Blazor Server is quite good and should be used today.
Right. And when we were talking with Dan, that was one of the questions I had is, okay, say I want to start with server-side Blazor today, but then 6 months or a year down the line, I figured, I want to now go client-side, once it's released. And what was that going to take? And he really made it sound like it was going to be a simple process to just switch from server-side to client-side. And so even if you're thinking about going Blazor now, you can start that way, with server, and then just make that switch when it's finalized and out there for client-side, and you should have no problems.
And if there's a value for it. As I said, in many cases, your app's going to be smaller and lighter than being server-side than it will be client-side. Client-side really matters if you want to be that disconnected or that PWA, or you're trying to take advantage of some of the hardware available to you on the client. Those would be the three reasons to me to really care about the client side of it.
Yeah. And in my tests as a developer, I really noticed the difference in the build experience. Because it's just, you're in Visual Studio, you just hit F5, build it, all that. You don't have to worry about NPM packages, Webpack scripts, anything like that to get that build of your client side, and then maybe a separate build for your server side APIs and things like that. So it really is, in my tests, made that so much.
That's one of the benefits we have with the Blazor tech. So, a lot of folks come to us and go, oh, you're trying to compete with JavaScript. No, we're not. Maybe Dan already told you this, but our goal is, we don't see Blazor as being going against Angular, React or Vue or whatnot. Our job is to give you choices. We give you choices to build mobile apps or desktop apps or web apps. Blazor is just another one of those choices. If it's easier for your team to use C# on the client and the server, then Blazor is an awesome opportunity. I mean, is an awesome feature. And then, as you said, it gives you one single tool chain. Whether you're building server or client, you don't have to go grab a bunch of other components to go stick in your build chain. It's the same MS Build tool chain we've had for 20 years. You don't have to go grab more stuff to stick in there. The only thing you'll see, which you probably saw playing with it, is when you do build a client-side Blazor app, you can see it trying to link out some of the stuff right before it runs.
Right. So something else new in 3.0 is the ability to do WPF and WinForms. Is that right?
Yeah, that's a interesting thing. So it's funny. It feels like in the last 5 years we've become really, really webby, with a lot of folks moving to the web for all their applications. With the single page apps and stuff like that. The reality is, when we look at the telemetry in Visual Studio, we find that we still have millions of people doing desktop development. And that was one of the reasons that we brought the desktop frameworks to .NET Core. We did two things along the way. First off, the premise all along has been that .NET Core is open source. So we went and worked with the Windows team to open source WPF. We are the team owner for WinForms, so we open sourced it. So they're both open source, but they both take contributions. We brought them because we saw we had millions of developers still in that space, and we wanted to make sure that we gave them a core solution. And if you're one of those developers, one of the reasons you might want to think of why would you move your WinForm or WPF app to core Well, you get a bunch of benefits. You get those new language features that you just talked about, C# 8, and in the future, C# 9. You're going to get this full side-by-side support, including the single exe, which means you can deploy the app in your enterprise. I used to have companies come to me all the time, and they're like, yeah, I can't move to 4.7 because my enterprise machines all have 4.6 on them, and so I can't target to that new version of the framework. With single exe desktop applications, when we ship a 5.0, you don't have to wait for IT to put 5.0 on any machines at all. You basically make the single exe option, you deploy the apps on the machines, and it just friggin' works. So that I want people not to have to ever wait like they had to wait in the .NET Framework world. You have to wait for your company to decide to put the new version of .NET Framework on the machines. You don't have to wait anymore. And you get the benefits of one of the fun demos I like to show is due to the fact that we can make side-by-side in .NET Core, we can change APIs that we would never be able to change in .NET Framework. And so the networking APIs in .NET Core are much faster than the networking APIs in .NET Framework. The file I.O. Operations are going to be much faster in .NET Core than they were in .NET Framework. And I think you have a topic on your list. Even some of the JSON parsing stuff. We introduced a lightweight JSON parser inside of .NET Core 3.0. That's going to be faster than any of the existing JSON parsing. And so I think if you're a desktop developer and you're still maintaining the application, moving to Core is going to give you perf. It's going to give you ease of deployment. And access to all the new bells and whistles that are a part of Core.
So of course these aren't going to be cross-platform.
Nope. Some people are like, oh, it's cross-platform, and I'm like, you have to realize what those technologies are built on top of. WinForms is technically a wrapper around HWind. That's a handle to a window. That's the tech in Win32 that the desktop apps kind of build on top of, and so you can't really port that. The only people that have ever ported it is there's a project out there called Wine, W-I-N-E, and that lets you run Windows applications on Linux. But then I would challenge that WinForm app's going to look like a Windows 95 app on a Mac. That's probably not what somebody would want.
Right. I dealt with HWind back in the VB6 days, and so there's a lot of that for that. So it's totally understandable. Is there any sort of magic that you can see in the future where you can make something cross-platform, WinFormy type thing? Maybe that's...
We've done a couple of Blazor demos to kind of lead down that path. So I think we will give you all the options in Blazor. So there's the options in Blazor that we can give you is number one, PWA. There's a community package today that does that for you. That makes your Blazor app feel like it runs not in a browser window. It still is a browser, but it doesn't look like it. It doesn't have the browser menus and stuff like that. So that's an option. Another option we have with Blazor, and we've shown prototypes of this as well, is running Blazor Electron. So Blazor Electron is pretty cool because, if you want to think of an Electron application, for people that don't know what that is, VS Code is an Electron application. What that is you take Chromium and you run that in a window, and you kind of run a web app inside of that Chromium. So VS Code is technically a web app. Electron apps get a bad reputation sometimes for being fat and big, because not only do you have the client part of the web app, the frame and the browser, but there's also a server running as well. And for most Electron apps, that's a Node.js server. But we have some cool tech where we were able to make Blazor work in that as well. So you're not running a Node.js Electron app, you're running a C# Electron app.
I think I read a blog post recently that you were looking at various alternatives to Electron, trying to get that package size smaller.
Yeah, well, even doing .NET in Electron ends up making it smaller and faster than the Node.js ones, just because differences in the tech. It's not a war against tech. We're precompiled, they're interpreted. We're less files on disk. There are more files on disk. So there's just stuff that can make that interesting. And so I think Electron will be an option there. So you're going to have, server, client, PWA, Electron. There's a journey along that path. And there might be more to it than just that. We are always exploring, is there a cross-platform UI thing that makes sense? And we have some experiments running right now. There's an experiment you can go find today called Comet. You can just go Google for .NET, GitHub, Comet, C-O-M-E-T. You can watch a video of what that looks like and download the code and try that code if you want. Blazor started off as an experiment as well. So in many cases, we try some stuff. In the old Microsoft, we would have gone dark for 3 years, worked on something, and then popped it out and hoped it was good. That's not how we design .NET anymore. So today, we would do some more experiments and say, here's something, try it. And if we get the right excitement around it, we'll see if we can take it further. There's another experiment likely to come out pretty soon, which is, Xamarin, any of the Xamarin tech, it's all based on XAML. People really like the Blazor programming model. And so we've been exploring, can we get Xamarin forms where you don't write XAML, you write Blazor HTML, and then that maps to, all the controls that exist inside of Xamarin.
Interesting.
And so there's that prototype's likely to come out pretty soon as well for people to try. And we just want to see if that's what people want.
I give that a shot.
I
would.
I think we showed a prototype briefly where we took Flutter and we mapped it in Blazor. And so you basically build your Flutter UI, which normally you would build it using Dart in your editor. And we're like, hey, that Dart's kind of ugly. What if you actually just wrote the UI and Blazor HTML kind of stuff? And it was cool to play with, and it got us excited, and that's what led us to thinking, could we go further with it? So we'll continue to do a couple of experiments like that, and maybe something will come out of it. I'm not going to commit to something today, but we're always exploring the next place.
No announcements on the show today, huh? Just for us?
I'm trying to think what could I announce today.
So where I work, we do a lot of data analysis with research, and one of the things I've been looking at is ML.NET.
Yes.
And trying to figure out how we could apply that to the data that we process. So how has that been changing as Core has progressed?
Yeah, the ML.NET space is interesting. So for people that don't know, ML.NET started off as an internal library that was used by many Microsoft teams. It was a library called TLC. And we ran into them many times, and we're talking to them, and we're like, hey, why don't we take this thing and make it available outside of Microsoft, make it open source? And that's where the genesis of ML.NET came from. In areas where you might see some of that tech is if you've ever seen a laptop or like a Surface device that has Windows Hello on it where you can unlock the screen with your face, that's ML.NET. If you're in PowerPoint and it gives recommendations of styles and stuff like that, that's ML.NET. So the tech inside of ML.NET has actually been used across a bunch of Microsoft products historically. So it's actually, battle-tested tech.
It's IntelliCode too, right?
Yeah. One of our goals with ML.NET is to go make that code more accessible to regular developers. And so what we've been doing is writing a layer on top of that library that makes the programming even easier for you and I to pick up and use. We did a demo at Build 2 years ago, and I remember the day before the demo, I'm asking the team, how did you choose the algorithm? And they're like, well, we just tried one and it seemed to work. And that's where a new tool that we introduced earlier this year called Model Builder came out. And the idea behind Model Builder is, you said you have some data. And if you go to our page, if you go to dot.net and click machine learning, there's a whole bunch of, we have a whole page full of example things you might want to do with ML.NET in your company. And Model Builder takes the approach, and there's a sample behind each of those. Model Builder takes a new approach, which is choose one of those, give us the data. We'll then run that data against all of our algorithms and try to give you a model and the code to actually paste into your application. We just released a new version of this today. It's the first version that supports images. And so one of the demos I did today was I took a folder on my disk with a couple thousand images of rainy days and sunny days and cloudy days, and I fed them into this wizard inside of VS. You're then given the choice of you want to train it locally or in the cloud. And typically for training a model, you actually want to train in the cloud because you want to give it a couple days to really crunch everything. And you select one of those options, and you select next, and then it will actually either use your local machine to train or to go up to the cloud in Azure, sit on a machine for however long you told us to train on the machine. It will then download the model back to your machine, put the model into your project, and it will then give you a class library that has the code to easily consume the model. And so in my case today, 3 lines of code. I create what's called a model input. I set the model input to the path of my file, and I say predict, and it returns a string, and it tells me if it's cloudy, rainy, whatnot.
It's almost more clicks than typing.
That's the hope, is it's more clicks than typing, or at least it's a good place to start you. And that's just one of the types of things we do. One of the demos we've done in the past is another option on that screen is sentiment analysis. And I'll give you a great example why people would care about sentiment analysis. Imagine you have a blog, and people put comments on your blog. Would you like to know when bad comments show up on your blog? I know I would. Let's say you're in GitHub and people are filing issues on your product. Would you want to know which are the most angry issues being filed against you? And all it takes is, for this is once again, is we went and found a bunch of reviews, public review data on the web, fed those text files through ML.NET, created a model, and then we just go give it text from one of these things, and it would tell us good or bad. And so we're trying to find, I like to say we're trying to find a way to democratize AI and make it available to more and more customers.
Is there a spam detector?
There is a spam detector in there as well. Yes, actually, one of the samples we have up there is a spam detector.
You see that so much on blog posts and things like that in the comments. So
yes, I mean that
would be really good.
Once again, those are easy to train. I mean, the big challenge on AI for most people, you just have to realize you probably have the data anyways. One of the other samples we built, it was the sample we built for build that year, was what we called the GitHub classifier, and that was something that would actually go and take an issue that was filed and move it to the right area. And of course, we had plenty of training data for like 5 years. My team has been sitting there every day and moving stuff to the right paths. And so you basically feed 5 years of us moving stuff through the system into it, and then you find out it can do it in about 98, 99% accuracy.
All right. So one other thing that I've been hearing at the conference here has been some talk about microservices. What would somebody use microservices for?
Microservices is one of the most overloaded terms I've ever heard in my life. So we go through this wave at Microsoft. I talk to a lot of customers, and they'll all come through, and we're going to move to microservices. What that really means, what I've learned over time, is you can interpret that two ways. Microservices means that you're either going to modernize your application, and you're thinking that as you modernize your application, you're going to break it into more pieces. What we find, most companies have a monolithic application that, because of the way it's put together, it's hard to build the entire thing as a single unit, and they would love to break it into like 2 or 3 pieces so they can move faster. So that's one form of microservice, but there's not really a micro in there. That's kind of a macro service. The second form of microservice that we hear is, if you look at the tech that my team builds, we've been building ASP.NET for forever, but most ASP.NET renders HTML. People always say there's either you either have a controller or you have a view. We've not really had super lightweight flavors of that. And so the other form of microservice is, hey, I want, if you call a URL called foo/bar, I want to run this C#. And that's a piece that our tech supports that, but we've never really helped you get there. And so if you're using newer bits and you do file new empty web project, you'll basically get that application now, where there is no controller folder, there is no view folder, there is no MVC, there is just, here, write some code that says, when you call this, run this C#, and you call this, run this C#. The cool thing about our tech is it's all meshable. So one of the demos I did today, I actually had a controller folder because I had a couple of APIs. But in a couple cases, I just wanted to return a file if you hit a URL. So I wrote 3 lines of code in my startup CS saying, if you call this URL, do this. And so we want to make sure that people realize that .NET is awesome at this. If you want to build something that's super small, that uses not very much of the .NET stack, you can. If you want to have full MVC, you can. If you want to have somewhere in between, you can. We did introduce a new template in the .NET Core 3 wave called the worker service. And the whole point of worker service was, in this microservice-y world, you might have long-running services. And we've never had a template. Our templates have always been these web apps or APIs. And so the worker service, the point of it is, even though there's no ASP.NET in it, you still get configuration, you still get logging, you still get dependency injection, you get all of the things you would expect in a modern ASP.NET application. But instead of running a web thing, basically it runs with a background task, and it'll run until you tell it to stop. And in my sample today, I showed a real-world version of this. I had an API inside of that would go out and call an endpoint. That endpoint's rate limited. I can only call it 50 times a day. So my worker sits there and calls that 50 times a day, stores the results in a cache. That's my microservice. And then I put GRPC and REST endpoints on that to return the values from the cache. So I took a service that can only be called 50 times a day and made my service let you call it 1,000,000 times a day. And so, we're trying to give better guidance and better advice on how to build these types of apps with .NET. But our big goal is .NET does not just mean ASP.NET, does not just mean web pages. .NET can be the same simple, if you've seen a Node.js style microservice, it's like 6 or 7 lines of code. We can do the same thing.
I saw the demo. Yeah, it really did make it seem really simple to create a service.
Yeah.
I've made a few in the past, and it seemed to be a little hair pulling at times. But from what the demo showed me, I think that's going to be much easier for people to do that need that.
I hope so.
Yeah.
One of the biggest pain points that I find as I talk to people about software is deployment. It's really interesting to have the conversations with people where I don't want to deal with Docker. I don't want to deal with Kubernetes. I don't want to deal with setting up servers. I don't, all of these different things. And in a lot of ways, DevOps has gotten a lot easier. And in a lot of ways, DevOps has also kind of embraced a certain amount of culture around applications, the way we build them, the way we deploy them. I've really felt for a long time that developers need to have the conversations with DevOps or adopt some form of DevOps so that they can take control of what they're doing and really understand when things go to production, what's going on, so that they can help debug the issues and fix the issues and find the issues when they go wrong and help streamline things and make things better and slicker and easier so that they'll more generally go right. So we started a podcast called Adventures in DevOps. I pulled in one of the hosts from one of my favorite DevOps shows, Nell Shamrell Harrington from the Food Fight Show, and we got things rolling there. And so this is more or less a continuation of the Food Fight Show where we're talking about the things that go into DevOps. So if you're struggling with any of these operational type things, then definitely check out Adventures in DevOps. And you can find it at adventuresindevopspodcast.com.
So in the last few minutes that we have, I think we should kind of cover about the future, and that would be .NET 5, and I call it the Grand Convergence.
The Grand Convergence. So the .NET 5 is a funny topic. Obviously, as we did .NET Core 3, you can imagine us all thinking about, is the next one .NET Core 4? And then we have to explain there's a Core 4 and a Framework 4, and which is which, and that's confusing. And so I hate to do this because, you're just following everybody else. You skipped a version. So we decided to skip a version, and we'll call the next one .NET 5. And we consider this to be a unified platform, meaning that, today if you build a Mono application or a Xamarin application, you go and reference Mono. You don't know you do this, but you're doing this. That's a different project system. Our goal is to make everything look the same. So in the .NET 5 world, the Xamarin projects will have the same SDK style project system that we have for the .NET Core projects today, which also means it makes it very easy to call back and forth between everything. So it means in this world, your WinForm, your WPF, your ASP.NET, your GRPC, your REST, all these apps will all use the exact same project style. They'll all use the exact same BCL. So the idea today is, most people don't realize this. We actually make 3 BCLs. We make the one for .NET Framework, we make the one for .NET Core, and we make the one for the Mono stack, which is what Xamarin runs on top of. Looking at me, you can tell that building 3 of these things, keeping them in sync is a bad idea. So we want to have one BCL across all the techs. So that's a piece of .NET 5. Another piece of .NET 5 is we want to take that single exe thing we talked about earlier. You were calling out, hey, it's kind of fake single exe. We want to make that real single exe. And so we want to do things like we want to optimize across the assembly barriers. There's a bunch of things we can do with our existing tech to make that app smaller and faster. That'll come in the .NET 5 wave as well. Another thing we're looking at in the .NET 5 wave is, you might have heard, depending on the tech you look at, there's this notion of what we call hot reload. Some tech has it, some tech doesn't. So hot reload is like Flutter does this. You save something in your code file in Flutter and it updates immediately. We just introduced in Xamarin. We've shown this in preview a couple times now, where, hey, if you change the XAML in your Blazor in your Xamarin app, and your device refreshes instantaneously. We added this for XAML for WPF a couple of years ago, but I want to make all the .NET work this way. So imagine you're building your ASP.NET application, you save your Blazor file or CSHTML file, and it refreshes in your browser right away. You're building a Blazor app, you save, it refreshes right away. We want to make that, we call this the inner loop. We want to make that as fast as possible. So .NET 5 is about converging the tool chains to all match the same, the BCLs to all match the same, to have a hot reload experience across all of our tech. I don't know if we'll get all that in, but that's the goal. And then the other goal is, moving forward, we want .NET Core or .NET 5 is actually just a continuation of .NET Core 3. We don't plan to bring any more tech back in to the stacks.
So will standard still be a thing? With everything is converging, is there a reason to still have? Is there going to be another standard?
.NET Standard, I think, is going to be important for us for a while still. So when I think of .NET Standard, the real goal with .NET Standard when we first came up with it was we didn't have any good way of sharing code across all of our .NET stacks. So if you're building a class library and you want to share that with a Xamarin app, it was no easy way to do that. We had a thing called portable class libraries, so that we had before. Mm-hmm. And basically, the more frameworks you chose, the smaller the number of APIs got, until it got to the point of being useless if you actually clicked everything. And so the idea with .NET Standard was have a huge, rich number of APIs that work across all the .NETs. And so even as we move into .NET 5, .NET Framework's not going away. I already said that. You likely might want to have class libraries that you share across a .NET Framework project and a .NET Core project or a .NET 5 project. And so .NET Standard will be helpful for that scenario. Another one to think about is even today with .NET Core 3.0, that shipped with .NET Standard 2.1. There's only 2 stacks today that implement .NET Standard 2.1. That's Xamarin and .NET Core. And so if you build a class library that's .NET Standard 2.1 compliant, it works across both of those app types. So you're going to have two or three choices. One is .NET Standard 2. That works across everything. UWP, .NET Framework, Xamarin, and .NET Core. 2.1 will give you all the latest APIs, but only across Xamarin and .NET Core. And so I don't think the value of either of these is going to go away anytime soon, because I don't think we're going to get to a point where there is no .NET Framework anytime soon. As I like to tell people, .NET Framework is a part of Windows. I've got a team in Redmond working on it every day. We will continue to support it and build it. And my advice to customers, new apps on .NET Core, leave your existing apps where they are unless you're actively working on them, and then consider moving them to Core to get to some of the benefits. What I don't want people to think, again, is that because we shipped the .NET Core and it's the new thing, all your old stuff has to move. No, you're in great shape. A whole bunch of Microsoft runs on .NET Framework and will forever.
Yeah, it totally makes sense. So as we wrap up here, I kind of have one last question, and it's probably a little bit off topic.
Okay.
I submitted a job application to Microsoft in 1986. I haven't heard back yet. You think I still have a shot?
I think you probably have to resubmit, because whatever job system we had in 1996... 86. Well, I promise you the job system we have today is not the same as the one in 86. All up, that's a great question. Applying for a job at Microsoft is... people don't realize that we get millions of resumes per year. I have no idea how we sift through those millions of resumes and they get to my desk or somebody else's desk. If you want to work for Microsoft, what I would say is find the team that you want to work for, find somebody on that team on Twitter, or find their email address and reach out directly to them and have a conversation with them. The best way to get into Microsoft is via a referral. All right.
So I want to thank you for taking your time in your busy day and being on the podcast. So I really appreciate it. Thank you.
Thank you. Thanks for having me.
One thing before we leave, I want to let all of our listeners know that we recorded this at Microsoft Ignite, and Microsoft is giving away Microsoft Surface earbuds to listeners. So if you want to enter, visit aka.ms/podcast sweepstakes. And you have to enter before December 15th of 2019. So if you want to win Microsoft Surface earbuds, go to aka.ms/podcast sweepstakes. Thanks, everybody. We'll see you next time.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.